Hello, my name is Zhuyan.
And my name is Luis. We are part of the Duursum network and we perform research aiming a more sustainable future for our planet.
We're here today to tell you a little bit about sustainability in construction and how new materials can improve the life quality of our world while delivering the same level of confidence of traditional materials for construction projects.
Did you know that concrete is the second most used material in the planet behind only water? So this means that concrete is the most used man-made material in the planet. And we can all see the benefits of concrete in our daily lives because concrete was used to build the highways where we drive, the buildings where we live, the bridges where we cross, and several other major and minor products.
But did you also know that while delivering a reliable performance for different applications, it is also responsible for a huge amount of carbon dioxide emission? This is one of the main villains of global warming.
Well, to begin with, let's quickly explain what is concrete. So concrete is made basically of a mixture of three elements: water, aggregates, which can be both fine, like sand, or coarse, like gravels, and the most important one, Portland cement. And this mix will result in products like this, or even in products like this. So the main material of this mixture of concrete is Portland cement, which will act as a binder or as a glue. And this is the glue that will provide most of the strength of the final products of concrete. But also, since this is the main material, this is also the most pollutant material of all. The production process of Portland cement can be divided in 5 different stages. The first step is the extraction of limestone and clay from natural reserves, which will provide the main constituents of clinker. This extraction process produces large rocks which must be converted into fine powder. The rocks are transported and fed into a two-step milling process, initially with crushing of larger rocks and secondly with secondary milling. The fine rocks of limestone and clay are burned in rotatory kilns to form the reactive phases of clinker, which is the main phase of Portland cement and is responsible for promoting the hardening effect of this compound. These kilns are lighted at temperatures above 1400 degrees, and this stage liberates the largest portion of carbon dioxide of the whole process. After burning, clinker is kept in silos to promote homogeneity of humidity before further stages. Further on, clinker is mixed with other compounds such as gypsum and admixtures and maintained in silos for final homogenization. Cement is then finally sacked and transported to its final destination, which can be construction stores, construction sites, or other places. This is the whole production chain of Portland cement, a raw material which, although plays an essential role in our lives, has a large carbon footprint in all stages of its production, with the extraction of natural resources, consumption of high levels of energy, and emission of carbon dioxide. At the end, around 0.8 tons of carbon dioxide is liberated to the environment for each 1 ton of concrete which is produced.
So, how can we maintain the same level of performance and still help our planet? We have one answer: alkali activated concrete. This new material can be referred to as green concrete and is much similar to the conventional concrete we just showed, with only a few differences. While water and aggregates are still used, the alkali activated concrete has 2 extra materials. The first one is the activators, which are chemical products used to create a new atomic structure of the final product. And the second is the precursors, which usually are the industrial byproducts.
And as you can see, the raw materials are much similar to the mix of conventional concrete. The biggest difference is that while a conventional concrete uses Portland cement as its main raw material, alkali activated concrete will use the industrial wastes, the precursors, as its main constituent. This means that not only we are avoiding the extraction of natural non-renewable resources, we are also decrease the amount of wastes that will be disposed in the nature, since precursors were already produced and they would be produced anyway. So different types of industrial wastes can be used as precursors. For example, fly ash, which are wastes from electricity generation plants, blast furnace slag, which are wastes from the production of steel, municipal solid waste incineration ash, which are wastes from burning garbage, recycled glass, and many others. The only requirement is that these industrial wastes have a similar chemical composition to Portland cement.
And how is this concrete made? Join us on our lab tour to check it out.
As we previously explained, alkali activated concrete or green concrete is composed of 4 elements: activators diluted in water, aggregates, and the most important, precursors or industrial wastes. The process of obtainment of alkali activated concrete is similar to conventional concrete. First, the aggregates are added and mixed in the mixing drum. Secondly, the precursor is added and a dry mix is performed. For last, the activator diluted in water is added to the mix. The mixing time is dependent on the type of concrete you are working with. Concrete is removed from the mixing drum and taken to the casting place. Then, concrete will fill the molds and will be vibrated to release air bubbles and internal voids. It is then wrapped to avoid the loss of water, and finally it is left to cure. After 24 hours it can be demolded and is ready for the final setting, which can take from 2 to 7 days. Final setting time also varies with the type of concrete mix you are working with. And this is the final product.
As you can see, a final product made of alkali-activated concrete is as hard as one made from traditional concrete. But can we trust in alkali-activated concrete? Of course. We can say its value has already been proved with several successful examples in the whole planet. Our job as researchers is to improve the quality and level of confidence on this type of construction materials, aiming to spread this technology and provide it to you as a guaranteed construction material for the future of our lives.
Therefore, we can count with green concrete to shape the future of our cities in a more sustainable way. We hope you enjoyed our explanation and gain a little bit of knowledge on how our work is contributing to a more sustainable development of our home planet. Please leave your questions and we will be happy to answer during these days of the event.
Goodbye to you all.
Bye bye.